Hello students, welcome to this lecture on statistics. In this lecture, we will explore NCERT section 13.5.2, 13.5.3 and example 9 to 13. This is disclaimer. So we will start with standard deviation of a discrete frequency distribution. Then we will solve example 9, which shows how to calculate the standard deviation for a discrete frequency distribution. Next, we move to standard deviation of a continuous frequency distributions. Then we will solve examples 10 and 11, which will help us practice finding the standard deviation for continuous frequency distributions. So students, let's get started. So first of all, we are going to learn how to calculate variance and standard deviation, which are two important measures in statistics. So let's start by considering a set of data where each observation is called xi and each observation has a frequency which we will call fi. Step 1 is to calculate the mean, which we call x bar, and x bar is equal to sum of fi times xi is divided by n. So in this formula, fi stands for the frequency of each value xi, and xi is the value itself, and n is the total number of observations which we get by adding up all the frequencies. So n equal to summation fi. Step 2 is to calculate the square deviations xi minus x bar whole square. Step 3 is to multiply each squared deviation by its frequency. So for each value, we calculate fi times xi minus x bar whole squared. Step 4 is to add up all these products. So we get sum of products is summation fi times xi minus x bar whole square for all values. Step 5 is to calculate the variance, which we will call sigma squared. So we do this by dividing the total square deviation by n. The total number of n is basically total number of observations. So variance is sum of fi times xi minus x bar whole square divided by n. So variance sigma squared equal to sum of fi times xi minus x bar whole square divided by n. And another important measure in statistics is standard deviation. So standard deviation, which is just the square root of the variance. So the standard deviation is sigma equal to square root of sum of fi times xi minus x bar whole squared divided by n. Now let's look at example 9. So in this example, we have to find the variance and standard deviation for the following data. So the table shows two rows. The first row xi list the data values for 8, 11, 17, 20, 24 and 32. And the second row fi gives the frequency of each value. Okay, and the frequencies are 3, 5, 9, 5, 4, 3 and 1. And then you have to find variance and standard deviation. So first of all, try it yourself. So let's solve this example step by step. To solve this example, we need to use the formula for variance. Okay, so try to recall the formula for variance. So the formula for variance is variance sigma squared equal to sum of fi times xi minus x bar squared divided by n. The where x bar is the mean and x bar is calculated by this formula, sum of fi times xi divided by n, and n is basically sum of fi from I equal to 1 to n, and fi is frequency of the given data and xi is a data point. So let's organize our data in a more useful way. So we will create a table that includes xi, fi, and also fi times xi. So pay attention to this table, okay, and see the given data. So in first column we have the values of xi, in second column we have the values of fi, and in third column we calculated fi times xi, okay, and the bottom of the table we calculated n equal to summation I equal to 1 to 7 fi, and the totals is 30, and sum of fi xi from I equal to 1 to 7 is 420. From table, we have n equal to 30 and sum of the products of each fi and xi is 420. Now, let's calculate the mean of the dataset. The formula for the mean in a frequency distribution is mean equal to sum of fi into xi from I equal to 1 to 7 is divided by n. So here value of fi into xi from I equal to 1 to 7 is 420, and the value of n is 30. So x bar equal to 1 by 30 times 420, and after calculating, the mean in this dataset is 14. Next, we will prepare to calculate the variance. So now we will add 3 column xi minus x bar, xi minus x bar whole squared, and fi times xi minus x bar whole squared, where x bar is 14. So the new table will be look like this. Okay, so this is our new table. So here we added xi minus x bar column, xi minus x bar whole squared column, and fi times xi minus x bar whole squared column. Okay, and here we calculated in the bottom of the table summation fi times xi minus x bar whole squared from I equal to 1 to 7 is 1374. From table n equal to 30 and sum of fi xi from I equal to 1 to 7 is 420, and sum of fi times xi minus x bar whole squared from I equal to 1 to 7 is 1374. Now let's recall the formula for variance in a frequency distribution. So variance written as sigma squared, and the formula is equal to the 1 divided by n times the sum of fi times xi minus x bar whole squared from I equal to 1 to 7. Now let's substitute the numbers into a formula. So we have variance 1 by 30 times 1374. When we multiply 1 by 30 by 1374, then we get 45.8. So the variance for this data set is 45.8. Finally, to find the standard deviation, we take the square root of the variance. So standard deviation written as sigma equals square root of variance. So square root of variance, that is here variance of 45.8. So square root of 45.8 is approximately equal to 6.77. So standard deviation sigma equal to 6.77. So I hope this example is clear to all of you. Now let's start by looking at how we can handle continuous frequency distribution in statistics. So when we have data grouped into classes, so we can actually turn this into a discrete frequency distribution by replacing each class interval with its midpoint. So this makes it easier to apply the formulas we already know for discrete data. Once we have replaced each class with its midpoint, we can calculate the standard deviation just like we do for a discrete frequency distribution. Okay, so this means we use the same steps and formulas as before we used for discrete frequency distribution. Okay, suppose we have n classes, each with a midpoint xi and frequency fi. The standard deviation, which we will call sigma, is calculated using the formula sigma equal to square root of 1 divided by n times sum of fi times xi minus x bar whole squared from I equal to 1 to n, where x bar is the mean of the distribution, which we calculate by taking the sum of all fi times xi divided by n, and n is simply the total frequency or the sum of fi from I equal to 1 to n. Now let's look at another formula for standard deviation. So we start with the definition of variance for group data. So variance written as sigma squared equals 1 divided by n times the sum from I equals to 1 to n of fi times xi minus x bar whole squared. Here n is the total frequency and fi is the frequency of the ith value, and xi is the value itself, and x bar is the mean. Now let's expand the squared term in the formula. So 1 divided by n times sum from I equal to 1 to n of fi times xi square plus x bar square minus 2 times x bar into xi. Next, let's distribute the fi across each term inside the parenthesis. So this gives us 1 divided by n times the sum of fi into xi squared plus the sum of x bar square times fi minus sum of 2 times x bar into fi times xi. In each case, I from I equal to 1 to n. Now let's factor out the constant from the sums. So x bar 1 divided by n times summation I equal to 1 to n fi times xi square plus x bar square times summation I equal to 1 to n fi minus 2 times x bar times summation from I equal to 1 to n of xi times fi. The variance sigma squared written as 1 divided by n summation from I equal to 1 to n of fi times xi square plus x bar square times sum from I equal to 1 to n of fi minus 2 times x bar times sum from I equal to 1 to n of xi times fi. Now let's simplify the formula using properties of summation. So we substitute sum of fi as n and sum of xi fi as n times x bar. So the equation becomes variance sigma squared equal to 1 divided by n of sum from I equal to 1 to n fi times xi square plus x bar square times n minus 2 times x bar into n into x bar. since 1 by n sum from I equal to 1 to n xi fi is x bar, and it implies summation from I equal to 1 to n xi times fi is n times x bar, and sum from I equal to 1 to n fi is n, and this is equal to 1 divided by n of sum from I equal to 1 to n of fi times xi square minus x bar square, and this is simply equal to 1 divided by n sum from I equal to 1 to n fi times xi square minus sum from I equal to 1 to n fi xi divided by n whole square, and this is equal to 1 divided by n square times sum from I equal to 1 to n of fi times xi squared minus sum from I equal to 1 to n of fi times xi whole squared. Thus, standard deviation sigma equal to 1 divided by n of square root of n times sum of fi times xi square from I equal to 1 to n minus sum from I equal to 1 to n of fi times xi whole squared. So now, shortcut formula for variance is sigma squared equal to summation fi times xi square divided by n minus summation fi times xi divided by n whole squared. Now, let's look at example 10. So let's examine our grouped frequency distribution and see how to find the mean, variance and standard deviation of the following distribution. Okay, so the table shows class intervals like 30 to 40, 40 to 50 and so on, and in second row it shows frequency 3, 7, 12, 15, 8, 3 and 2. Okay, so let's try to solve this example first, okay, and then see the solution. So let's look at solution of this example. So we will solve this example step by step. To start of this solution, we need to find the variance. Okay, the variance measures how spread out the data is around the mean. So the formula for variance sigma squared equal to sum of fi times xi minus x bar whole square divided by n, where x bar is the mean and x bar is calculated by this formula sum of fi times xi divided by n, and n is sum from I equal to 1 to n of fi, and fi is the frequency and xi is the data point. Now, standard deviation is simply the square root of the variance. So standard deviation sigma equal to square root of variance. From the given data, we construct the following table. So look at very carefully this table. Okay, so in this table we added new column midpoint and we calculated fi times xi for each xi. Okay, so look at here in the bottom, n equal to sum from I equal to 1 to 7 fi, and this is equal to 50, and sum from I equal to 1 to 7 fi xi is 3100. So here you may ask how we find midpoint xi. So 30 to 40, here the midpoint is 35. Okay, so we have taken here average of lower limit and upper limit of that specific class. Okay, and we obtain midpoint xi. From the table, we see that the total frequency n is 50 and sum of all frequency times midpoint values is 3100. So these are written as n equal to sum from I equal to 1 to 7 of fi equal to 50 and sum from I equal to 1 to 7 of a5 times xi is 3100. So we will use these two numbers to find the mean of the distribution. Thus, mean x bar equal to 1 is divided by n times sum from I equal to 1 to 7 of a5 times xi. This is equal to 3100 divided by 50 and this is simply equal to 62. Now, to calculate variance and standard deviation, we need to add three new columns to our table. They are xi minus x bar column, xi minus x bar whole square column, and fi times xi minus x bar whole squared column, where x bar is 62. So the new table will be look like. So this is our new table and here we added three new column, xi minus x bar, xi minus x bar whole squared, and fi times xi minus x bar whole squared. Okay, and then we calculated n and sum from I equal to 1 to 7 fi xi and sum from I equal to 1 to 7 fi times xi minus x bar whole squared, and this is equal to 10,050. Now, from table, we have sum from I equal to 1 to 7 of fi times xi minus x bar whole squared equal to 10,050 and n equal to sum from I equal to 1 to 7 of fi equal to 50. And the formula for variance in a frequency distribution, that is variance sigma squared equal to 1 divided by n of sum from I equal to 1 to 7 of fi times xi minus x bar whole squared. Now let's substitute the values we have into the formula. So we get variance. This is equal to 1 by 50 times 10,050 and this is simply equal to 201. And standard deviation sigma is nothing but square root of variance. Okay, and here we have calculated variance sigma squared is 201. So standard deviation sigma equal to square root of 201 and here the square root of 201 is approximately 14.18. Okay, so this value gives us a sense of how much the data typically varies from the mean. Okay, and we have calculated here mean, variance and standard deviations for the following distribution. Okay, so I hope this example is clear to all of you. Now let's look at example 11. Okay, so in this example we have to find the standard deviation for the following data. Okay, so the table shows in first row the values of xi and the values of xi are 3, 8, 13, 18 and 23. Okay, and second row shows the values of fi and fi is basically the corresponding frequencies of xi. Okay, so the values of fi are 7, 10, 15, 10 and 6. So first of all, try it yourself and then see the solution. So let's solve this example step by step. To solve this example, we need to use the formula for standard deviation for group data. So let's start by recalling that the standard deviation measures how spread out the data values are from the mean. So we will use a specific formula that works when we have frequencies for each data point. So here is the formula. We will use sigma equal to 1 divided by n times square root of n times sum from I equal to 1 to n if I times xi square minus sum from I equal to 1 to n if I times xi whole squared. So we will substitute our values into this formula step by step as we solve the problem. Here fi is the frequency, xi is the data point, and n equal to sum of fi from I equal to 1 to n. Now to solve this, we will first organize our data in a more detailed table. So this helps us keep track of all the calculations we need for standard deviation. So we will include columns for xi, fi times xi, and xi squared, and fi times xi squared. So this setup will make it easier to compute the sums required for the formula. So look at this table. So here we added column of xi, fi, and fi times xi, and xi square, and fi times xi square. Okay, and then we take total of fi sum from I equal to sum of, okay, summation fi is 48, and this is n, and sum fi xi is 614, and summation fi xi square is equal to 9652. From table, we have n equal to sum from I equal to 1 to n if I is 48, and sum from I equal to 1 to n if I xi is 614, and sum from I equal to 1 to n of if I times xi square is 9652. So now we will use these values to calculate standard deviation. So standard deviation formula, sigma equal to 1 divided by n times square root of n times sum of fi times xi square minus sum fi times xi whole square. So let's substitute our values into the formula. So we have sigma equal to 1 by 48 times square root of 48 times 9652 minus 614 whole square. Now let's simplify this. So the expression under the square root becomes 463296 minus 376996. Okay, and then we divided this number by 48. So this is equal to 1 by 48 times 293.77, and this is approximately equal to 6.12. Okay, this is our calculated standard deviation. Therefore, standard deviation sigma equal to 6.12. So I hope this example is clear to all of you. That's all for today's lecture, and thank you for your attention. I hope this lesson was helpful to all of you.